Welcome back. In this video we're going to talk about vectors in R3. This is a continuation of our discussion of vectors in R2 as part of our work in multivariable calculus. Recall that the main push of differential calculus in multiple variables was to study the forward problem of multivariable differentiation, which was to take the gradient operator applied to a multivariable function and produce a vector-valued derivative where the first component of this vector is the partial derivative of capital F with respect to x, and the second component is the partial derivative of capital F with respect to y. In this paradigm, we focus on functions z, which is the output variable, equal capital F of x comma y. This would be the output of our multivariable function, and then here we have two input variables, x and y. Notice if we group input and output together, we get an ordered triplet, which is the input x comma y corresponds with the output z, and in function notation you might write x comma y corresponds to the output f of x comma y. This is analogous to the work we did in calculus. (1a). In particular, remember that in calculus we studied this derivative operator applied to a single variable function, and then we produced the derivative, which in prime notation looked like this, right? When we were looking to interpret the meaning of the ordinary derivative graphically, we grouped input and output of f of x together to form ordered pairs x comma f of x, or if you were so excited about the output that you wanted to call it x comma y, where y was equal to f of x, right? And the concept here was we could now graph, if we thought about the input-output relation between the single variable function is I put in the input and I get the output, I can now graph the function behavior on the Cartesian coordinates, and that allows me to interpret the ordinary derivative on the graph as the slope of a tangent line. In multivariable calculus, we're going to use the same idea, but we're going to do it in R3, three-dimensional coordinate system, where the input to our graph exists in what we call the xy plane, and the output represents height. And what's really fun about this is when we go to interpret the directional derivative, or excuse me, the gradient of this function, we can now do so with reference to the surface that is formed by graphing all ordered triplet of this type. So in order to get our head around this, we're going to introduce R3. So the whole idea here is to develop the idea of graphs and slopes of tangent lines to surfaces. We need to understand R3. And that's what this lesson is all about, developing intuition about ordered triplets so that we can use this intuition to build surfaces and use our understanding of surfaces to build derivatives, which are slopes of tangent lines to those surfaces. It's kind of the motivation for this. In the next video, we'll start getting into the specifics about R3. I'll see you there.